Logarithmic differentiation. This is a method for finding the derivative in certain situations. One of these situations is this one. You have x to the x, a variable to a variable. We cannot use the power rule, which works when you have variable to number. We cannot use the exponent rule, which is when you have number to variable. So we need a different method. What we're going to do is take the log of both sides. You can choose any base you want. I'm going to choose base e, which is written abbreviated ln, because the derivative is slightly simpler. So what we've done is take the ln of both sides of the equation. That allows us to bring down the exponent. That's one of our log rules. And now we have a product on the other side, which we know how to deal with. We'll take the derivative of ln y, 1 over argument, times derivative of argument. So the derivative of y is 1 times dy dx. You remember that from implicit differentiation. On this side, we have a product rule, derivative of first times second plus first derivative of second, which is 1 over argument times derivative of argument, which is just 1. X times 1 over x will simplify to 1. And then we're going to multiply both sides of the equation by y to get rid of this fraction. So we'll end up with a y times ln x plus 1. And instead of writing your answer with y is equal to x to the x. So we'll replace y with x to the x. Let's do that again. Variable to variable, there is no rule for that derivative. So we're going to take the log of both sides. We're choosing base e, abbreviated ln, because the derivative is slightly more simple. Once we've taken the ln of both sides, you can bring the exponent down. It's one of your log rules. We then take the derivative of ln y, 1 over argument, times derivative of y, which is 1, chained with dy dx. Product rule, derivative of first times second, plus first derivative of second. X times 1 over x simplifies to 1. Multiply both sides of the equation by y. That will bring the y to this side. And replace the y with x to the x. So how do you know when to do this? Anytime you see variable to variable. The other time you'll know to do this is when you see a question that looks quite monstrous. The quotient rule with a product rule on the top and chain rules. It's going to be very confusing if we try and take that derivative. What we're going to do instead is take the log of both sides. Once we've taken the log of both sides, we can now use the log rules that say when you have a product, you're allowed to change that to addition. And when you have a quotient, you're allowed to change that to subtraction. So the ln of sine to the 7, x squared plus 2x plus 1 to the 10 over x cubed minus 1, the ln of sine x to the 7, plus, because this is multiplication, the ln of x squared plus 2x plus 1 to the 10, minus the ln of x cubed minus 1, because that's a quotient. Now, what else can we do? Another log rule, bring down those exponents, and that will get rid of the chain rule. So by taking the ln of both sides, we've managed to get rid of products and change it to addition, quotients, change it to subtraction, power rules, and change it to multiplication. Much simpler. Take the derivative now. Derivative of ln y, 1 over argument, derivative of argument. 7 times ln sine x, 1 over argument, derivative of argument. 10 times ln x squared plus 2x plus 1, 1 over argument, derivative of argument, minus ln x cubed minus 1, 1 over argument, derivative of argument. Cleaning that up, we'll multiply both sides of the equation by y, and then look for anything else that you can simplify. There's a 2 that's common here. If we pull the 2 out front, we can combine it with the 10 and get 20, and factoring out the 2 leaves us with x plus 1. Where did this cotangent come from? Cosine over sine can change to cotangent. It doesn't look like there's anything else we can do, so that would be our final answer. Let's try that again. You have a monstrous question. Quotient rule involving product rules involving chain rules. Take the ln of both sides. The log rule that allows you to change multiplication to addition and quotient rule to subtraction. That's what's coming into play now. So products become added, quotients subtracted. Then we can bring down the exponents. And then we take the derivative. The derivative of a ln, 1 over argument, derivative of argument. We apply that again and again. The numbers out front just get multiplied by the derivatives. So 1 over sine, derivative of sine is cos. 10 times 1 over x squared plus 2x1. Derivative of x squared is 2x. Derivative of 2x is 2. 1 over x cubed minus 1. Derivative of x cubed is 3x squared. Cosine over sine becomes cotangent. Then factor a 2 out of here. It would be 2 times x plus 1. Multiply the 2 by the 10. Yes, it is a lot of writing, but it is a lot less thinking than it would be if we tried to do a quotient rule or the product rule with some chain rules. Why don't you try this on your own? Y equals the root of x cubed plus 4 over x cubed minus 1 to the 5th. Start by taking the ln of both sides. Use the log rule that says when you have a quotient, we're allowed to subtract those. Then we'll use the log rule that says you're allowed to bring the exponents down. Keep in mind that this is really exponent 1/2. Then take the derivative of both sides. You have to be careful here. You tend to do a fair bit of writing before you take a derivative. Remember that all we've done is simplify this side of the equation. Nothing's changing here. We have not taken a derivative yet. Remember to take the derivative. Derivative of ln y, 1 over argument times derivative of argument. 1/2 multiplied by the derivative of ln x cubed plus 4. 1 over argument, derivative of argument. Minus 5 times the derivative of ln x cubed minus 1. 1 over argument times derivative of argument. We're going to multiply both sides by y, and we're going to clean this up as well. When we clean it up, the 5 and the 3 become 15. 1 times 3x squared is 3x squared. The 2 is multiplied by the x cubed plus 4. So why do we multiply these together, but not those? If you multiply those in, it'll just make your numbers bigger. Yes, it made this number bigger as well, but if you were plugging in for x, that would be one thing to do rather than 2. You wouldn't work out 3x squared and then multiply by 5. Here, you'd work the bracket out first before multiplying by 2, and that keeps your number smaller. So single terms we multiply together, but multiple terms we tend to keep factors. And where did this term come from? When you multiplied both sides of the equation by y, we replace y with what it was equal to in the beginning. So we'll look at that again. We took the ln of both sides, changed the quotient to subtraction, brought down your exponents. This is really 1/2, and this is 5. Took the derivative of both sides using the log rule, 1 over argument, derivative of argument. Cleaned it up as much as possible, multiplied the 1 in, said the 2 is multiplied by that. 5 times the 3 became 15. When you multiply both sides by y, we replace the y with what it's equal to. You'll get better at these the more you do. So on page 2, part D, you're going to do 1 to 10. If you have any questions, let me know.